This question is from GATE 2018, Mechanical Engineering Paper Set 1, question number 40. A machine of mass m equal to 200 kg is supported on two mounts, each of stiffness 10 kN per meter. The machine is subjected to an external force in Newton, F of t 50 into cos 5t. Assuming only vertical translatory motion, the magnitude of dynamic force in Newton transmitted from each mount to the ground is dash. We need to find the force that is transmitted from each of these springs or mounts. The expression for transmittability or transmittability ratio is given as transmitted force Ft divided by amplitude of the force applied, that is F naught. In the given question we have F of t is equal to 50 cos 5t. So if we compare this to the general expression of external load or applied load, we have F naught cos omega t, and hence F naught is 50 Newton. It is given that the force is in Newton, so F naught is 50 Newton and omega is 5 rad per second. So this is the exciting frequency, omega 5 rad per second. Coming back to the transmittability ratio, it is force transmitted divided by magnitude of the external force. This is given as root over 1 plus 2 zeta r whole square divided by 2 zeta r whole square plus 1 minus r square whole square. Now in the given question, we do not have any damper in the system, so damping ratio is 0. R is, however, given as the ratio of exciting frequency to the natural frequency. Exciting frequency is known, we need to find the natural frequency. Natural frequency of this system can be found using stiffness equivalent. Because there are more than one spring, we have to calculate the equivalent stiffness divided by the mass. Hence we have, as the springs are in parallel, we know that the stiffness will be added to get the equivalent stiffness. Hence we write K1 plus K2 divided by M. Stiffness of each spring is 10 kN per meter. So converting it to Newton per meter, we get 10 plus 10 into 10 to the power 3 Newton per meter divided by mass is 200 kgs. So we get omega n to be root over 20,000 divided by 200 gives us root over 100, and which is 10 rad per second. We have the natural frequency, the exciting frequency. We can calculate the ratio R. That is nothing but 5 by 10, which is 1 by 2. Putting the zeta value and the R value in transmittability ratio, we get Ft by F naught is equal to, wherever there is zeta, we can put 0 and those terms will go to 0. So we have 1 plus, this term becomes 0. This term also becomes 0 plus 1 minus r square whole square, which is equal to 1 by 1 minus r square whole square. If we take the root of this value, we get 1 upon 1 minus r square. Hence, transmitted force through the mounts is equal to F naught upon 1 minus r square, which is nothing but 50 upon 1 minus 1 by 2 whole square. This is calculated as 66.67 Newton. But we need to find the force transmitted by each mount. So for each mount, we have force transmitted by each mount to be Ft by 2. That is nothing but 66.67 divided by 2. This is calculated as 33.33 Newton. So the answer here is 33.33 Newton is the force transmitted from each mount to the ground. For more information on transmittability, you can refer to the NPTEL video W03M05 Transmittability from the course Structural Dynamics by Raman Charla Pradeep Kumar. He is from Earthquake Engineering Research Center, IIT Hyderabad. I hope this solution will help you clear your doubt. Thank you.